Good morning, good afternoon, good evening, all the students in your standard 10 NCERT textbook. Chapter number 2 is polynomial. We start polynomial from very simple definition of polynomial. Poly means many. The Latin word poly means many and nomial means terms. Those has many terms is known as polynomial. Polynomial has many terms. Polynomial means many terms. Those have many terms is known as polynomial. You learn about polynomial in 9th standard. There you learn the three types of polynomial: binomial, monomial and polynomial. Binomial has one term. Monomial has one term, binomial has two terms, and polynomial has more than three terms here. And also you learn about linear polynomial, quadratic polynomial and cubic polynomial. And also you learn about the degree. The degree is the highest power of variable. In polynomial there are variables are alphabets from A to Z. We can use alphabet for as a variable. Here first linear polynomial, quadratic polynomial and cubic polynomial. Linear polynomial has a degree is equal to 1. The highest power of the variable in any polynomial you say and highest power is 1, therefore it is a linear polynomial. Second is quadratic polynomial. The highest power of the polynomial is 2. It become degree is equal to 2 and it become a quadratic polynomial. And cubic polynomial the degree is equal to 3. Some examples of linear polynomial are given here. P of x is equal to 9x plus 5, P of y is equal to minus 6y plus 3, and P of x, example of quadratic polynomial, P of x is equal to 2x square plus 6x plus 7, and P of y is equal to 9y square minus 3y minus 6. Example of cubic polynomial, P of x is equal to 6x cube plus 3x square plus 3x plus 6x minus 3 minus 3y square minus 3y plus 3y minus 9. Common form P of x of linear common form of linear polynomial, P of x is equal to x plus b. Common form of quadratic polynomial, ax square plus bx plus c, and the common form of cubic polynomial, P of x is equal to x cube plus bx square plus cx plus d, where a does not equal to 0. B and C and D you can put 0, but A is always not equal to 0. If you put A is equal to 0 in linear polynomial, so it become only constant number, because the multiplication of 0 with x it gives 0 and remains only B, therefore it become any constant number. And here x square plus bx plus c you can put, if you put here a is equal to 0, then 0 into x square plus bx plus c, 0 into x square becomes 0, therefore bx plus c, bx plus t has highest power 1, therefore it become linear polynomial, so we can't put a is equal to 0. Graphs of the polynomial are shown here. For linear, the graph is straight line. For quadratic polynomial, it's parabola. If upward direction parabola, if you find upward direction parabola, this is a show that the coefficient of x square, is plus 2. The coefficient of x square is plus. The upward direction parabola show that the coefficient of quadratic polynomial of x square is plus positive, and the downward direction parabola shows that the coefficient of x square of quadratic polynomial is negative. It shows that it is a negative, and it shows that it is a positive. Upward direction coefficient positive, downward direction coefficient negative, and the cubic polynomial graph you will see here. Point 1. Question number 1. Find the number of zeros from the given graphs. The first graph is there you see there the graph of the polynomial of x. It doesn't touch x-axis, therefore the number of zeros equal to 0 because it not touches the graph of the x-axis. Second, y-axis, x-axis. You can see here the graph of the polynomial is touched only one time to x-axis, therefore number of zeros is equal to 1. In third, you can see here the graphs of the polynomial touches x-axis in 1 time, 2 time and 3 time. Therefore the number of zeros is equal to 3. X-axis, y-axis. Fourth, you can see here the parabola. You can see here this graph is a parabola. It is a graph of quadratic polynomial and this is a upward direction. So we can say that the coefficient of the polynomial, the coefficient of the x square of the polynomial is positive, and there are 1 and 2 time the graph touches to x-axis. Therefore number of zeros for this polynomial is 2. Fifth, the graph touches x-axis 1 time, 2 time, 3 time and 4 time. Therefore the number of zeros for this polynomial is 4. This graph is 4. And the last, you can see here the graph touches 1 time, 2 time and 3 time. Therefore it is a cubic polynomial and the number of zeros are 3. Exercise 2.1 is very simple. How? Exercise 2.1 is very simple because in the first question in this exercise only find the number of zeros, and number of zeros are finding from how many times the graphs are touches to the x-axis. The graph of the given polynomial is touched to x-axis. It touch 1 time, therefore it is a linear polynomial. It touch 2 times, it is a quadratic polynomial, and if it touch 3 times, therefore it is a cubic polynomial. Next, exercise number 2.2. The next topic in chapter is this: the relation between zeros of quadratic polynomial and coefficient of quadratic polynomial. The coefficient of the quadratic polynomial a and b and c. A and b and c, and the zeros of the quadratic polynomial are 2, and we give the name alpha and beta. Zeros and a, b and c are coefficient. A, B and C are coefficient. Common form ax square plus bx plus c is equal to p of x. The coefficient are A, B and C. Now the relation between alpha and beta means the zeros and quadratic zeros and the coefficient A, B and C. We see here alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. The relation between zeros and the quadratic and the coefficient of quadratic polynomial are alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Now we start the exercise 2.2. Exercise 2.2. Remember, here we use only relation between zeros and coefficient of quadratic polynomial. The relation between zeros and quadratic polynomial are alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Let's see the question number 1. In question number 1, first question number 1 is find the zeros of the given polynomial and prove the relation between zeros of the polynomial and coefficient of the quadratic polynomial. The question number 1 is x square minus 2x minus 8 is equal to p of x. For find zeros, you also teach in 9th standard. For finding zeros, p of x become zeros. P of x become 0. Therefore, x square minus 2x minus 8 is equal to 0. There are two kinds of methods are there. First is multiply the first and last 8x square. Find the factors of 8x square. That from subtraction we got minus 2x. Find the factors of 8x square. From 8x square factors doing subtraction we got minus 2x. Means first term and last term multiplication gives 8x square, and find the factors of 8x square that subtracted from each other become minus 2x. Therefore, there are two factors 4x and 2x, but we want minus 2x, therefore the bigger factor become minus and another factor become plus. Therefore, we can write this as x square minus 4x plus 2x minus 8 is equal to 0. In 9th standard, this method is known as splitting middle term. Splitting middle terms. Now, from first two step and last two step. First two step में से common x minus 4, from last two step, last two terms 2x minus 4. Now you here see that x minus 4 and x minus 4 common from these two terms, therefore x minus 4 is common and remains are x plus 2 is equal to 0. Now here two brackets are multiply and the answer is 0. That means any one is equal to 0, but we can't say x minus 4 is equal to 0 or x plus 2 is equal to 0. So we got x minus 4 is equal to 0 or x plus 2 is equal to 0. We don't have idea which one is 0, but we use both are. Therefore x is equal to 4 and x is equal to minus 2. Therefore alpha is equal to 4 and beta is equal to minus 2. Now the relation. Relation between zeros and coefficient of the quadratic polynomial. Alpha plus beta is equal to minus b by a. Put the value of alpha. Alpha is 4. Beta is equal to minus 2 is equal to minus b. B की value divided by a. Minus b from the polynomial minus b is equal to plus 2 and b is equal to minus 2. Therefore minus 2 divided by a is equal to 1. 4 minus 2 is equal to 2. यहाँ पे 2 minus minus plus plus 2 divided by 1. 2 is equal to 2. Therefore the relation between alpha and beta, therefore the relation between coefficient and zeros are proved. One another is remain. Alpha into beta is equal to c by a. Alpha, the value of alpha is 4, the value of beta is equal to minus 2 is equal to c by a. The value of c is minus 8 and a is plus 1. It is equal to minus 8 upon 1. Therefore minus 8 is equal to minus 8. Minus 8 is equal to minus 8. Therefore we can say that the relation between coefficient and zeros are proved. The relation between coefficient and zeros are. Second question, p of x is equal to 4s square minus 4s plus 1. For finding zeros, first step is p of x is equal to 0. Therefore 4s square minus 4s plus 1 is equal to 0. Therefore now the same method we can use, or another method is this is a x square minus 2ab plus b square. Therefore it become a minus b whole square, but we use the same method. Multiply the first term and last term, it equal to 4s square, splitting the middle term minus 2s and minus 2s become the 4s square. Factors are 2s and 2s, so minus 2s minus 2s it become minus 4s. You can see that 4s square addition 2s and 2s. We want minus 4x is equal to minus 2s minus 2s. Therefore 4s square minus 2s plus 1 is equal to 0. Therefore from first two terms and from last two terms common something. From first two terms common 2s, therefore 2s minus 1, and from last two terms common 1, but here we want the same bracket as like this, therefore, and we have minus 2s plus 1 and we want 2s minus 1, therefore we common minus 1 such that it bracket become 2s minus 1. Therefore first terms and second terms we common from 2s minus 1 from first term and second term, therefore 2s minus 1 is common and another bracket 2s minus 1 is equal to 0 is equal to 0. Therefore we can say that the first bracket is equal to 0 or the second bracket is equal to 0, therefore 2s minus 1 is equal to 0 or 2s minus 1 is equal to 0, but 2s is equal to plus 1 or 2s is equal to plus 1 and s is equal to 2 and s is multiplication, therefore 2 goes to left and right hand side of the equal to, it become dividend, therefore 1 by 2 or s is equal to 1 by 2. Here alpha is equal to 1 by 2 and beta is equal to 1 by 2. Relation between alpha and beta and coefficient ABC are alpha plus beta is equal to minus b by a. First relation proved, alpha plus beta, alpha is equal to 1 by 2 and beta is equal to also 1 by 2. The value of b is equal to 4, the value of a is equal to 4. Now alpha 1 by 2 plus beta 1 by 2 is equal to minus b, the value of b is equal to minus 4 divided by a, the value of a is equal to 4, minus plus 4 plus 4 and plus 4 are cut, therefore it become 1. 1 by 2 plus 1 by 2 is equal to 1 is equal to 1. First relation proved. Second relation, alpha into beta is equal to c by a. Alpha into beta, the value of alpha is equal to 1 by 2, the value of beta is equal to 1 by 2, the value of c is 1 and the value of a is 4, therefore 1 by 4. The multiplication of 1 by 2 and 1 by 2 is equal to 1 by 4 is equal to 1 by 4. Therefore we can say that the relation between zeros and coefficient of polynomial is proved. Question number 3, 6x cube minus 3 minus 7x is equal to p of x. Six x square minus 3 minus 7x is equal to p of x. Here, first of all, the power of the first term is 2, the power of the second term is 0, and the power of the third term of the variable is 1. Therefore, this is not an proper form. The proper form is ax square plus bx plus c. So, first of all, we arrange this in proper form. Ax square plus bx plus c is equal to polynomial of x. For finding zeros of polynomial, p of x become 0, therefore 6x square minus 7x minus 3 is equal to 0. 6x square minus 7x minus 3 is equal to 0. The same method we can use here. 6x square into 3, it gives us 18x square minus 18x square. Find the factor of 18x square or minus 18x square. Doing subtraction, we got 7x. The factors are 9x and 2x. Minus 9x plus 2x. Minus 9x plus 2x, it gives minus 7x. Therefore, 6x square minus 9x plus 2x minus 3 is equal to 0. 6x square minus 9x common, 3x. Therefore, remains are 2x minus 3. Plus 1 is common, remains 2x minus 3 is equal to 0. Therefore, 2x minus 3 common and remains 3x plus 1 is equal to 0. Therefore, 2x minus 3 is equal to 0 or 3x plus 1 is equal to 0. Therefore, x is equal to minus 3 goes to right hand side, it becomes plus 3, and 2 is in multiplication in left hand side, it goes to right hand side, it go to in division. Therefore, x is equal to 3 by 2 or x is equal to same minus 1 by 3. Therefore, alpha is equal to minus 3 by 2 and beta is equal to minus 1 by 3. Now, the relation between coefficient and zeros of the polynomial. Alpha plus beta is equal to minus b by a. The value of alpha is minus 3 by 2 and value of beta is equal to minus 1 by 3. Minus 3 by 2 minus 1 by 3 is equal to minus b. The value of minus b, from this is not a proper form of polynomial, so we can't use it. We use this. There is a b is minus 7. Therefore, we put minus 7 divided by a. A is equal to 6. Here we use LCM because there is a one mistake. Alpha is equal to 3 by 2, not minus 3 by 2. There we use LCM of 2 and 3 is 6. Therefore, 3 3s are 9 minus 1 2s are 2 divided by 2 into 3 LCM is 6. Therefore, 7 by 6. Therefore, 7 by 6 is equal to 7 by 6. 9 minus 2, 7. 7 by 6 is equal to 7 by 6. So, another relation, alpha into beta is equal to C by A. Alpha is equal to 3 by 2 and beta is equal to minus 1 by 2. Therefore, multiplication of 3 by 2 and minus 1 by 2, and the value of C is minus 3 and the value of A is 6. It becomes minus 3 by 6. 3 to the 6. 3 minus 1, 3 into minus 1 minus 3 divided by 4 is equal to minus 1 by 2. Another relation, alpha plus beta is equal to alpha into beta is equal to C by A. The value of alpha is 3 by 2 and the value of beta is equal to minus 1 by 3. The value of C is equal to the value of c is equal to minus 3 and the value of a is equal to c. Minus 3 divided by 6. 3 cancel, it become minus 1 by 2, and here 3 to the 6, it become minus 1 by 2. Therefore we can say that the relation between alpha, beta and coefficient a, b, c is proved. Or also you can write the relation between zeros and coefficient of quadratic polynomial are proved. Question number 4. 4u square plus 8u is equal to p of u. Here you saw that ax square plus bx plus c, there is no constant terms. Therefore we use another method for finding zeros. For finding zeros, p of u become 0. Therefore 4u square plus 8u is equal to 0. From the both, 4u is common. 4u is common, remaining u plus 2 is equal to 0. U plus 2 is equal to 0. From both, 4u is common. Here remain u and here remain 2 is equal to 0. The multiplication of two terms is equal to 0. Therefore we say that any number of term is 0. Therefore 4u is equal to 0 or u plus 2 is equal to 0. Therefore u is equal to 0 because 4 goes to denominator. 0 by 4 is become 0, or u is equal to minus 2. Therefore alpha is equal to 0 and beta is equal to minus 2. Relation between zeros and coefficient of polynomial is alpha plus beta is equal to minus b by a. Therefore put the value of alpha, alpha is 0, plus the value of beta, beta is equal to minus 2, is equal to minus b by a. The value of minus b, minus 8 divided by a is 4. 4 to the 8. 0 minus 2 is equal to minus 2 is equal to minus 2. First relation proved. Second relation, alpha into beta is equal to c by a. The value of alpha is 0, 0 into beta. The value of beta is equal to minus 2 is equal to c by a. The value of c, there we can't see c. Therefore the value of c is equal to 0 and divided by a is equal to 4. 0 by 4, 0, 0 into minus 2, 0. Therefore 0 is equal to 0. Therefore we can say that the relation between zeros and coefficient are proved. Relations between zeros and coefficient of quadratic polynomial are. Question number 5. T square minus 15 is equal to p of t. For finding zeros, p of t become 0. For finding zeros, p of t become 0. Therefore t square minus 15 is equal to 0. Therefore t square is equal to minus 15, left hand side goes to right hand side, it becomes plus 15. Therefore t is equal to plus or minus root 15. Plus or minus root 15. Therefore alpha is equal to plus root 15 and beta is equal to minus root 15. alpha is equal to plus root 15 and beta is equal to minus root 15. Relations between alpha beta and the coefficient of quadratic polynomial are alpha plus beta is equal to minus b by a. Alpha, the value of alpha is root 15 and minus root 15 is equal to b. We can't see here b, therefore the value of b is equal to 0 and divided by a is equal to 1. Root 15 minus root 15 is equal to 0 is equal to 0 by 1 is equal to 0. The another relation, alpha into beta is equal to c by a. Alpha into beta, the value of alpha root 15, the value of beta minus root 15 is equal to c. The value of c minus 15 divided by a 1. Root 15 into minus root 15, it is equal to minus 15. Therefore, minus 15 divided by 1 is equal to minus 15. Therefore, minus 15 is equal to minus 15. Therefore, we can say that the relations between zeros and coefficient of quadratic polynomial is proved. And number 6, p of x is equal to 3x square minus x minus 4. P of x is equal to 3x square minus x minus 4. For finding real zeros, p of x is equal to 0. P of x is equal to 0. Therefore, 3x square minus x minus 4 is also equal to 0. Therefore, from using the method splitting middle term 3x square into 4, it becomes minus 12x square. Minus 12x square, subtract, find two factors of minus 12x square and subtract each other, and answer is minus x. Therefore, the factors are 4x and 3x. We want minus x, therefore bigger factor become minus and smaller factor become plus. Therefore, 3x square minus 4x plus 3x minus 4 is equal to 0. Therefore, first two step common something, first two step common x, therefore remaining are 3x minus 4, and second two terms and last two terms common plus 1 remains are 3x minus 4 is equal to 0. From first and last term common 3x minus 4 and remains are x plus 1 is equal to 0. We know that the multiplication of any two numbers or any two objects is given 0. Therefore, any one is become 0. Therefore, 3x minus 4 is equal to 0 or x plus 1 is equal to 0. Therefore, 3x is equal to 4. Therefore, x is equal to 4 by 3 and here x is equal to minus 1. Therefore, alpha is equal to 4 by 3 and beta is equal to minus 1. The relation between coefficient and zeros of the polynomial alpha plus beta is equal to minus b by a. Alpha plus beta is equal to minus b by a. The value of alpha is 4 by 3 and beta is equal to minus 1. 4 by 3 minus 1 is equal to minus b by a. The value of minus b plus 1 divided by a, 3 minus 1 divided by 3. 3 ones are 3. LCM of the left hand side is 3. Therefore, 4 minus 3 divided by 3 is equal to minus minus plus 1 by 3. Therefore 1 by 3 is equal to 1 by 3. Another relation, alpha into beta is equal to c by a. Alpha into beta is equal to c by a. The value of alpha is 4 by 3 and the value of beta is equal to minus 1. Therefore multiplication of 4 by 3 into minus 1 is equal to c by a. The value of c is minus 4 and a is equal to 3. It is equal to 4 by 3. Minus 4 by 3. Therefore